Well, we're going. So we got our television camera positioned 4,000 feet from the base of a rocket launching pad. Yes. And the rocket rises vertically, and its speed is 600 feet per second when it has risen 3,000 feet. How fast is the distance from the television camera to the rocket changing at that moment? Okay, so this part A is something we've already done with triangles. So we can draw a picture of this. We've got our rocket. What should we call it? The red rocket. There we go. And here it is, straight down, and here is the base. 4,000 feet from that is the camera, just beautifully in. Does that look like a camera? Perfect.
Excuse me?
Hello?
Sorry for interrupting. Is it possible for you to come to the office just for a quick moment?
Yeah, she'll be right down.
Thank you.
Yeah. Okay. All right. So there's our camera, beautiful rocket picture. What's that?
Why would you put it on TV? People want to watch it on TV. It's kind of cool to see a rocket launch.
All right, have you? They used to do that all the time. You'd go. They'd even like whenever they were shooting a rocket into space, you'd like Apollo 13. You'd be like everybody be watching at home, and it was so exciting until that one blew up, and then they stopped showing them on TV. It's like, yeah, it like took off, and then it was like on the camera, and everybody's like, woo! It's not funny. You guys. Yes, everybody on the thing. It's nobody. I don't think anybody on the ground, but everybody in that rocket.
Got hit by something and died.
No, just everybody in all the
I
astronauts.
thought they don't send astronauts into space anymore. Like I thought they just sent.
No, America has stopped making rockets.
It's just
our
a-
world has stopped.
Yeah.
Oh, I thought they just sent like robots into space.
All right. Well, now that we've cleared that up, here's our picture. So we know that this is our y, and we know that y is a function of time, and we know that dy dt is how much it's increasing, how much it's going up, is 600 feet per second. You are going to be famous.
Why?
The sound will be on YouTube.
Okay? And we want to find out how much this is increasing, because that's the distance from the television camera to the rocket at the moment when it's 3,000 feet. So we're finding it at y equals 3,000. We want to find dx dt. Or sorry, dz. Is that all right if I use z for this one here in green? Because then you can do x squared plus y squared equals z squared. And it's another triangle question that we've done before. So how do we set up our equation for this one?
I don't know.
Good. That could be a problem.
I don't even know how to do this.
So first of all, at 3,000 for y, 3,000 plus 4,000, quick mental math, is?
7,000?
Nope. Oh yeah, 3,000 plus 4,000 is 7,000. But if you do a squared plus b squared equals c squared, 3,000 squared plus 4,000 squared equals z squared. Z will be 5,000. It's just the 3, 4, 5 triangle, just with more zeros. And how are these three things related? They're related by x squared plus y squared equals z squared.
Uh-oh.
What is dx dt? How much is this changing? 0. It's not changing at all. So now when we take the derivative with respect to time of this whole thing, we're going to get 2x dx dt plus 2y dy dt equals 2z dz dt. We are looking for the rate that the rocket's going away from the camera. So that's dz dt. We have values for everything here. Of course, this one's going to be 0 because dx dt is not changing. Plus, we're finding it out when y was 3,000 and its speed is 600 feet per second. So, big numbers, divide by 10,000, 6,000. What is this? Whew. Is that right? Do I have too many zeros? 5 on the top. One more on the bottom. Okay, good. Because I was thinking, if this is only... Wait a second. Something seems wrong here, though. Because if we simplify this, what do we get? 360. Would it be slower? Maybe. Is this increasing slower than that? Is it going faster up than it would be increasing? Maybe.
Are you still in trouble?
Whew.
Still in trouble?
That's, yeah, it would. Yeah, it would be just slower because it's on a hole.
How much is the rocket tall between 4,000 and the rocket?
I guess eventually it would approach when it's going almost straight up and down. They would be almost the same. But before that, it would be decreasing really quite slowly. Even though this is going up fast, this length might not be increasing that fast. So maybe this does make sense. I've got the answer key on the next page. I'm just trying to sweat it out here a little bit. So we got 360, what was it, feet per second? What are our units? Feet per second. Should we do the big test? Find out whether or not we can actually upload this? Got the answer key on the next slide. The answer key says 360 feet per second. Yeah, well, unfortunately the happy dance doesn't show up on YouTube. But we just did a happy dance that we got that one right. So there it is. There is the answer. 360 feet per second will be how much they're coming apart at that time. All right, so now we can go to part B. Should I stop recording, make B separate?